In section 3.1, we're going to graph things using pairs of numbers. And these are kind of special pairs of numbers. They're called ordered pairs. So they're going to have an x and y coordinate. Ordered pairs. And there's lots of good reasons that you would work with an ordered pair or a pair of numbers. And that's because quite often things that might be of interest to you occur in pairs. Like when you're watching your kid grow up, you're going to watch their age versus their height. Or maybe when you're older, you're going to worry about your height versus your weight. Make sure that that ratio is okay. So a lot of things do occur in these pairs of numbers. And it's no longer enough just to have one number line to represent them. You're going to need more than that. And it was René Descartes who in the 17th century said, hey, well, what if we drew two of these number lines perpendicular to each other? And that's what he did. We called the horizontal one the x-axis, and the vertical one was the y-axis. These two axes break up your paper, or more formally, the plane here, into four regions. Those regions are called quadrants. They're numbered starting in the upper right, counterclockwise around to the lower right, 1 through 4 using Roman numerals. And it's in these quadrants that we're going to graph our numbers, graph our pairs of points. So we'll start with point A here, which has coordinates of 3 and 2. What you want to keep in mind when you're looking at these things is that they're always understood to be the x-coordinate, then the y-coordinate. They're always in that order. So x, then y. If I find, say, x is 3, that's here 1, 2, 3 on the x-axis, then I go up 2 on the y-axis, and there's my point, the point 3, 2. So that's the first of my 7 points here. Let's take a look at point B here. Again, it's x and y. This time I'm to the left of the y-axis, -3, and then up 4. And B is going to be in the second quadrant. Now take a second for yourself and see if you can't finish things off. Finish off, all 5 remaining points, and they're going to be in the various quadrants. See if you can't find out where those points lie. So point C is in the third quadrant, -6 for x, -2 for y. D is in the fourth quadrant, 1 for x, but -4 for y. Where's E? Where am I going to find point E? Yeah, on the axis, right? E is right up here at 0, 2. So that's E. How about F? Same kind of thing. It's going to be again on one of my axes, F. And G is a special one. 0, 0, the center of it all. G has a special name. Does anyone know what it's called? The origin. So the point 0, 0 is called the origin. Now we'll see this again later, but just fill this in now. These ordered pairs are solutions of a linear equation. So, all right. Our goal right now is to get comfortable, with these pairs of points and what they represent. So we're going to kind of do this again in the backwards direction with problem number 20. Before I move on from this first part, though, are you okay with what we did in terms of plotting these points? All right. We're going to do a lot more work with plotting points. But for now, let's look at problem number 20 right here. And I'm not going to be able to actually draw or write down the solutions here as we go through it. But let's just look at a few points and determine their coordinates. So, Chelsea, how about the first one? What are the coordinates of point B? B. Yeah, 1 and 4. So 1 comma 4. Thank you. How about point E? Someone else for E. Carrie, thanks for volunteering. -5 and 5. So -5 for X, 5 for Y. Let's move down to C. I had a volunteer on the last one that I didn't get to call on. I think it's -4. Good, -4 and -3. Now make sure that you put those in the right order, and you did. But if you had them in the wrong order, -3, -4 would be right there. So it would be a completely different point. Last but not least, F. We're probably going to have to estimate F a little bit, right? What's F going to be? Nice. 1.5 and -3.5. That'd be my guess for F, right? Okay, good. Let's go back to our handout then. Let's look at a graph of a line, and we're going to use this graph to kind of fill in what's called a t-table. So, for instance, if the y-coordinate is 3, what's the x-coordinate? Well, let's find out. The y-coordinate is 3, that's right here. Move over to the line, bring it down. What's the x-coordinate that corresponds to that y-coordinate of 3? 1. So 1 and 3. I'm going to play that game again. This time y is going to be -1. So if y is -1, that's right here. And then back up at y equals 5. Y equals 5, we're right there. Let's keep going. We got a point if x is -2. I think this one's a little bit different. If x is -2, they're asking you for the y-coordinate. Good. And the last one is when y is 1. What's the value of x? So I'll give you a second to think about these things. I've got our graph marked up a little bit. So what x value goes with y is -1? -1. -1 and -1. So here's our y value of -1. It goes with x is -1. If y is 5, that was way up here. Y is 5. What x value goes with that one? 2. Let's move around to x is -2. -2, and yeah, -3. I'm with that one. Ooh, the last one. What happens if y is 1? What's the value of x? 0. Well done. So, big goose egg there on that last one for y is 1, then x is 0, right on the y-axis. All right, nice. let's actually start moving into some of the applications then of using this. And it's going to start with problem number 20, which is a very idealized graph of somebody's heart rate during a workout. So almost laughably idealized. Let's start by labeling these things. They tell us that this is 10, this is 20, 30, 40, 50, 60. And our first goal is to try and figure out how long was she in her training zone. So that would be this part right here. How long was she in the zone? Well, she hit the training zone 10 minutes in and was there till 40 minutes, right? So I think, Nick, you had the right answer here. 40 minus 10 would be 30 minutes in the training zone. All right. The next part of it, you're going to have to kind of estimate a little bit. Before I move on to the next part, her cool down, are you okay with our conclusion here? She hit the training zone here, about 10 minutes in, and was there till about 40 minutes in. So right down to here. 40 minus 10 gave us our 30 minutes. Dwayne, how long was she in the cool down zone? Let's see. Where did she start the cool down zone? Cool down zone. At what time? About 40 minutes. Where did she end it? Roughly what time? Yeah, it's between 50 and 60, so we'll call it 55. So about 15 minutes in the cool down zone. Are we okay with our 2 quick answers on this one? So, like I said, the actual graph here is pretty far-fetched. Here's some actual real training data. It doesn't look anything like that graph. So, but it makes it for an easy problem. So we'll stick with it. Let's turn back to the book for the next one. It's problem number 31. How many of you remember the game Battleship? Yay! All right, a few of us there that do. So the question is, what shots would you fire in order to sink what appears to be the submarine? I put some dots on it here to make it clear where we're firing. But what shots would you shoot? What are you going to call out? G4, G3, G2. Good. And I like the order that you gave those to me. You have the X coordinate, then the Y coordinate. So we can zoom out a little bit now. G2, G3, and G4. This is a nice update from the old book. The old book had a submarine going sideways, which would be like cheating, right? Can't do that. Okay, one more from this section, and it's problem number 40. Asked you about renting a boat. So renting a boat, they give you a little chart here of time and hours. I'm guessing this is a rowboat because this looks amazingly cheap. 20 bucks for 2 hours. Okay. You're not getting a jet ski for that kind of price. It'd be more like 60 bucks for 1 hour. In any case, let's see if we can't figure out a few things here that are asked by the problem. Says, how long does it cost to rent the boat for 3 hours? You have to kind of estimate a little bit, right? 3 hours up here. hours over here. About how much for 3 hours? $25. Good. How much for... How many hours could you rent this for if you had $60 to spend? Well, 60, I think, takes you all the way out to 10. So, all right, basically $6 an hour. There's a few more questions like this, but what I want to do with my time remaining is move into section 3.2. We'll finish up 3.2 later, but we're just going to keep rolling with section 3.2. Let me give you some homework for 3.1. For homework, try 17 through 21 and 29 through 35. Section 3.1, that starts on page 190, 191? Yeah, actually 192. On the back of your handout, you'll see where we're going in the next section, section 3.2. We're going to continue working with equations and points. And in particular, what we're headed to is working with the graphs of equations. But first, it's going to require we understand what the graphs kind of represent. So let me answer question 16 for you first. An ordered pair is a solution of an equation if the numbers in the ordered pair satisfy the equation. So if it fits in the equation, then great, it's a solution. So let's check out the first two here. This is your x-coordinate, this is your y-coordinate. How am I going to decide if this is a solution of this equation? Plug it in. So let's plug it in. So does 1 equal negative 2 times 2 plus 3? Is that true? Well, does 1 equal negative 4 plus 3? No. You get negative 1 on the right-hand side, you get 1 on the left-hand side, and those two are not equal. So no, 2, 1 is not a solution. Let's look at the next one. We're going to play the same game here. We're going to plug this into this equation and find out, well, is this a solution? So why don't you race me, see if you can win. Does 4 equal negative 1/6 times negative 12 minus 2? Does 4 equal 2 minus 2? No. So again, you're kind of out of luck. This is not a solution. On an exam, if I ask you to decide whether or not something is a solution, this is what I want to see. I want to see you plugging in that number into the equation. And then just say yes or no. Okay, that's good enough. But make sure that on an exam, you do this step. That's what I'll be looking for as I grade you. Now, this is kind of a silly game to keep on trying different numbers until we maybe stumble upon something that works in terms of it being a solution. So here's what we're going to start doing. We're going to start plugging in values for x, or sometimes y, and getting solutions, getting coordinates that satisfy our equation. So for problem 54, if I plugged in a 0 for x, what would I get for y? -1 for x gives me what for y? -4, -8. What about the last one? 12. Thank you. Now these really now represent pairs of points. For instance, the first one is a pair 0, 0, and then -1, -4, -2, -8, and 3 and 12. And what I want you to do, and you've got a graph real handy right nearby, is to graph these pairs of points and see what you see. But plot all these points. I'll get you started with the first one. That's the origin, 0, 0. I know, I'm so nice. But see what you get when you plot the rest of those. Is there something interesting that happens when you graph the rest of these? They all fall on the same straight line. So that's characteristic of these types of equations. That's why they're called linear equations, is because the graph is a straight line. You should expect that when you're graphing these things. Now, because you can always draw a straight line through any 2 points, I recommend that when you're graphing things, you graph at least 3 points, just to make sure that you haven't made a mistake someplace. Quite typically, when you're graphing these things, you're not going to be given a table with suggested values like this. You're just going to be given a problem like 42. And I'll say, here you go, graph it. So what you can do, especially with a problem like 42, is just make your own little table. And then choose your own little values. Then you choose any numbers you want. But what variable is solved for in equation in number 42? The y variable is solved for. So it's easy to feed in values for x. So what would be some easy values for x to put in? What's the easiest one? 0. All right. We'll also throw in -1 and 1. You can throw in 2 or 6 or whatever. Keep in mind, though, your graph has to be big enough to accommodate those points. Marianne, if x equals 0, what does y equal? If I put in a 0 here, what do I get for y? 3 times 0 plus 1 would be 1. All right, so let me do that over here. 3 times 0 plus 1 would be 0 plus 1, which is 1. So 0 for x, 1 for y. Carry, 3 times -1 plus 1, what would I get there? Good, -2. And last but not least, someone else for x equal 1. 4. 3 times 1 is 3, plus 1 is 4. So I've got 3 points. Let's graph those. 0, 1 is right here. -1 and -2 is down here. And +1 and +4 is up here. Great. All 3 of those look like they lie on a nice straight line. What I like about this, in graphing 3 of these, is that you can tell right away if you've made a mistake. If you accidentally forgot a negative here, if maybe you graphed, say, 1 and -2 instead of -1 and -2. If you graphed 1, 2, or excuse me, 1, -2, it'd be down here. And you look at these and it forms a triangle as opposed to a nice straight line. That's telling you you've made a mistake. So it's a good way to double check yourself. And when I ask you to graph these things on an exam, I'll always be asking for 3 points. So get used to looking for 3 points. You know, another point you could have chosen that would have been very easy would be x equal 2. If x equal 2, y is 7. 2 and 7 up here. So, last one. Problem number 50-ish. If you're stuck coming up with your own points, you might want to make it as easy as possible. The difference between this one and the last one is I don't have y solved for. Now, the book tells you to solve for y in some of these. I don't really think we need to. Let's just do it this way. An easy value to plug in for x would be x equals 0. What's an easy value to plug in for y? 0. Yeah. Let's start out here. Plug in x equals 0. Plug in y equals 0. So if I set x equals 0, I get 2 times 0 plus 3y equals 6. So it's just 3y equals 6. What does y equal? 2. Let's set y equals 0. If y is 0, 2 times x plus 3 times 0 equals 6. X equals 3. I need one more point. And I've done the easy ones. Any suggestions? Keep it simple. -3 would work good. Somebody said 1. 1 for x or 1 for y? 1 for y? Okay. I like 1 for y. Because 1 for y is right between 0 and 2. So when I plug that in for x, I should get a value that's right between. Let's see what happens. So when I set y equal to 1, I get 2 times x plus 3 times 1 equals 6. So it's 2x plus 3 is equal to 6. Just 3 times 1 gives me my 3. Subtract 3 from both sides. 2x is 3. X is 3 halves. Most of you might be more comfortable thinking of that as 1.5. Let's plot these points. 0, 2 is up here. 3 and 0 is right here. And then 1 and 1.5, excuse me, 1.5 and 1. So 1.5 and 1 is about there. Okay, so just kind of zoom out a second. There's your graph. All 3 points lie on the same nice, neat, straight line. And everything is good. Lion and lamb are best friends. Republicans and Democrats are going to agree. All is right with the world. For homework, for right now, try 17 through 23, 37 through 43, and 53 and 50, or 53 through 57. That's section 3.2. See ya.